Okay, in 2.5, we're going to be introduced to the power rule. Okay, the power rule is to find the derivative. So if you recall, f prime of x, one way to find the derivative is to use this formula, limit as h approaches 0 of f of x plus h minus f of x over h, or you can use limit as x approaches a of f of x minus f of a over x minus a. And that was the formal definition of derivative, and we could always use that to find a derivative. But there is a shortcut sometimes. Okay, and we're going to use the power rule. Okay, the power rule only works when your function is the format of f of x equals x to some power. Okay, if that is the case, to find the derivative, f prime of x, I bring the exponent down, n, and then I lower it a degree. So over here, here's some basic functions. F of x equals x squared is in the appropriate formula. To find the derivative f prime x, I'm going to bring this 2 down, and I'm going to lower a degree, so now it's 2x to the 1, which is just 2x. Okay, I'm going to do the same on the next one. F of x equals x to the third, bring down the 3, so this is 3x, and I'm going to lower it a degree, so now it goes down to 2. Then f of x equals x to the fourth, bring the 4 down. 4x to lower the 4 a degree goes down to 3, and then for f of x equals x to the fifth, I'm going to bring down the 5. X, and now this is going to be to the 4th power. This is a really good shortcut if your function happens to be in the correct format. Okay, so we're going to use the power rule to find the derivative of the following functions. And if it's not in the correct format, I'm going to have to rewrite it a little bit. Okay, let's see. Derivative. Since they're giving me the notation f of x to indicate derivative, I'm going to say f prime of x. Okay, I'm going to bring down the 37, and I'm going to lower it a degree. So f prime of x is 37x to the 36th. And there's no way I would ever want to calculate this using the formal definition. Okay, let's look at the next one. Okay, it's y equals. So for notation, I could do dy dx, or I could do y prime. Either way is fine. I'm going to do dy dx this time. And that's a change of y in terms of x. Okay, if I want the derivative, I bring down the 9x, and I lower it to x to the 8th. Okay, let's see, y equals 1 over x. Okay, 1 over x is not the correct format. I need it to be an x to the something. So I'm going to rewrite it first. This is x to the, since the x went to the bottom, this is x to the negative 1. Okay, now I'm going to find the derivative. Since I'm starting with the notation y equals, I could do dy dx, or I could do y prime. I'll do y prime this time. Okay, now I'm going to apply the power rule to this expression. I'm going to bring down the coefficient, not the coefficient, the exponent. So negative 1 x to that, and I'm going to lower it a degree. When I lower it to negative 1 by a degree, it now goes down to negative 2. Okay, now we normally don't leave negative exponents in our answer, so I'm going to rewrite this. I'm going to say y prime equals negative 1 over x to the second, because it's a nicer way to write the answer. Okay, let's look at d. G of x equals 1 over x to the fourth. I am going to rewrite this because I want it to be in the format x to the something. Okay, since x to the fourth is in the denominator, let's make it equals x to the negative fourth. Okay, now because it was g of x, I'm going to do g prime of x equals, bring down the negative 4x, and I'm going to lower it a degree, so it's going to go down to negative 5. Okay, and then to make it look nicer, I'm going to rewrite it with positive exponents. So this is going to be negative 4 over x to the fifth. Okay, now let's look at e. E is y equals the square root of x. I can only use the power rule if I rewrite this as x to the some exponent, so I'm going to do that. Square root is a fraction exponent, so it's going to be x to the 1/2. Okay, now I can apply the power rule to y equals x to the 1/2. Okay, because it starts with y equals, I can do dy dx, or I can do y prime. I'm going to do y prime for no reason other than I'm lazy. Okay, I'm going to bring down the 1/2. x to the, now I need to lower this a degree. Okay, so I'm taking the 1/2 and I'm subtracting 1. I'm lowering it by a degree, which is 1/2 minus 2/2, which is -1/2. So this goes down to -1/2. Okay, now I'm not going to leave it like that because it's weird to leave a negative exponent. It's also kind of weird to leave a fraction exponent. Okay, so I'm going to rewrite it in two ways. This is 1 over 2x to the 1/2. Okay, but 1/2 just means square root, and it's nicer to write it as a radical. So I'm going to rewrite this as y prime equals 1 over 2 square root x. Okay, and this is the nicest way to write the answer, although you could do dy dx, which is arguably a nicer way to write it too. Okay, one more. F of x equals the 7th root of x to the 3rd. Okay, remember, must rewrite this with an x to the something so I can use the power rule. So it's x to the 3rd, but then I'm doing the 7th root. So I'm going to rewrite this as x to the 3 over 7. X to the 3rd, 7th root. Okay, now I can find the derivative. So f prime of x equals, I'm going to bring down the 3/7 x, and I'm going to lower the 3/7 by a degree. So if I do 3/7 minus 1, that's 3/7 minus 7/7, which is -4/7. Okay, and then I'm going to rewrite this because I've got fraction exponents, negative exponents, I've got all kinds of stuff going on. Okay, I'm going to move the x to the bottom. Okay, and then I'm going to do the 7th root of x to the 4th. And this is a nicer way to write it, so I'm going to leave it in this format like this. Okay, for example 2, it says simplify, then take the derivative. I don't know. Okay, this is the expression. This is f of x equals x over root x. I want to find f prime of 7. So I need to find the derivative of f of x, and then I'm going to substitute in 7 to find the actual value there. But this, I can't do power rule on this, so I'm going to rewrite it. Okay, so this is x over x to the 1/2. I still don't like it because I need it to be a single expression. This is x to the 1 over x to the 1/2, so I can subtract the exponents. 1 minus 1/2 is 1/2, so this is really x to the 1/2. Okay, now I can do the power rule on this. So f prime of x, bring down the 1/2, x to the -1/2. But remember, I'm going to rewrite it because I don't like it like that. So 1 over 2 times x to the 1/2, which is the square root of x. Okay, so I found the derivative of f of x, but they want me to find f prime of 7. So now I'm going to go ahead and substitute it in. 1 over 2 square root 7. Now let me look. Does that simplify? Square root 7 does not simplify. If I tried to rationalize by doing root 7 over root 7, I would get root 7 over 14, which is not a better answer. So I'm going to go ahead and leave it like this. So f prime of 7 is equal to 1 over 2 root 7. Okay, and do make sure you label your work. This is f prime of x. This is f prime of 7. Okay, let's look at part B. Same idea. I need to simplify this first before I apply the power rule. So let's see, f of x equals, let's make, instead of 3rd root, we're going to make it x to the 1/3 times x to the 3rd. Okay, now I can add the exponents. So I'm going to get x to the 1/3 plus 3, which is 3 1/3, which is 3 times 3 is 9 plus 1, which is going to be 10/3. Okay, now I can apply the power rule. So f prime of x equals 10/3 x to the, and I'm going to do 10/3, and I'm going to bring it down a degree. So it's going to be 10/3 minus 3/3, which is 7/3. I'm looking, am I going to rewrite? Yeah, I'll rewrite this. Okay, so this is really 10/3, and this is x to the 7th third rooted, which I could simplify, but I'm just going to plug it in anyways. Okay, let me go ahead and plug in the 8 then. 10/3 times the third root of 8 to the 7th. Okay, now the 8 is being third rooted and it's being raised to the 7th. You can do whichever part you want first. Because I know what the third root of 8 is, I'm going to go ahead and do that part first. The third root of 8 is 2. So this is 10/3 times 2 to the 7th. Okay, now I can do the 2 to the 7th. 2 to the 7th is 128. Which is going to give me 1,280/3. Okay, so what did I get for my answer? So for my answer, the f prime of 8 is going to be 1280/3. And I'm going to leave it improper, but it is simplified. Okay, let's go ahead and look at the last example. Okay, example 3. Let f of x equal x to the 4th and g of x equals x to the 3rd. At what value or values of x do the graphs of f and j have parallel tangent lines? Okay, parallel lines. What do we care about parallel? Parallel lines have the same slope, which in calculus means they have equal derivative values. Okay, so let's find the derivative of each of the functions. So if I do the derivative of f of x, I get 4x to the 3rd. If I do the derivative of g of x, I'm going to get 3x squared. Derivative is the slope, or an equation for the slope. So I want them to have the same slope. So I'm going to set them equal to each other so I can figure out when their slopes are equal or when their derivatives are equal to each other. Okay, I'm going to make it equal 0. I am absolutely not going to divide by x squared because I'm going to lose x squared versus answers. Worth of answers? Okay. Okay, let me subtract 3x squared. Okay, I can take out a common factor now, so this is going to be x squared times 4x minus 3. Okay, so if x squared equals 0, then x equals 0. If 4x minus 3 equals 0, x equals 3/4. Okay, did they only ask for the x values? At which values of x do the graphs of f and j have parallel tangent lines? So at x equals 0 and x equals 3/4, f and j have parallel tangent lines because both of their derivatives are equal to each other or the slopes are equal to each other.